Here's what I learned in my nuclear class. We started off by going over particles and particle sizes. So we're dealing mostly with subatomic particles, which are on the order of femtometers, which is 10 to the negative 15th meter. We talked about the fundamental forces of the universe. So there's electromagnetism, which is relatively straightforward. So is gravity. And then there's the strong and the weak nuclear forces. The strong force is what holds the nucleus of the atom together. So you have a couple protons. They would normally push apart. The strong force is what keeps that from happening. And the weak force is when you have an especially unstable nucleus of an atom, it allows some of the quarks that make up a proton or a neutron to flip direction so that it can change the actual element of the atom. So if you have an unstable helium and one of the protons turns into a neutron, it then becomes a hydrogen. We went over fission and why fission actually works. Basically, a uranium atom is relatively unstable because it's so large. So we inject one neutron into it and that destabilizes it and it splits into multiple component parts. And that releases both energy, it makes two new elements at least, and it releases more neutrons, which then run into surrounding uranium atoms, which then eject more neutrons, thus keeping the process going. Apparently one uranium pellet, which is the size of your fingernail, has the same energy as 3 barrels of oil, each of which is like 42 gallons, the same as 1 ton of coal, and the same as 1,700 cubic feet of natural gas, which is absolutely bonkers when you think about it. And with an inefficient reactor, 3 liters of uranium, which is a gallon of uranium, contains the same amount of energy as your average American consumes in their entire lifetime. And that's not just in terms of energy, like electricity consumption, it's also the food that you eat, the energy it takes to produce that food, all of those component parts, same amount of energy. Nuclear has the lowest amount of emissions per gigawatt hour of any kind of electricity that we produce. And turns out per unit of electricity, nuclear has the lowest amount of deaths. For example, you get about 32 and some change deaths per terawatt hour of coal, whereas you get 0.07 deaths per terawatt hour of nuclear. And almost all of those came from the 4,000 deaths at Chernobyl. That's crazy. God, I want to work in this field.